Hello, welcome to Tech Transform. Today we are here to discuss about another concept in Python that is called generators. Generators in Python, actually we have lot of we have seen lot of example to create functions with def and the return keyword. But generator function allows us to write a function that can send back a value and then later resume to pick up where it left off. That means, let's say we want to create a list of numbers up to 1 to n, means up to 1 to 10, then it's not going to hold all the list members inside the memory. Instead it will give you one value each time as you need. This type of function is called a generator in Python, allowing us to generate a sequence of values over a time, and it will be one by one. The main difference in syntax will be the use of yield statement. Here we are going to use a yield statement. Basically the main takeoff from this Python generators session is to knowing the yield keyword, and to basically understand how we can create generator using yield statement. And when a generator function is compiled, they become an object that supports an iteration protocol. Means if when a generator function is compiled, uh, it can allow you to iterate over that function. That means when they are called in your code, they don't actually return a value and then exit. It doesn't mean that it's a normal function that you will call that function and it will finally return and then exit. It doesn't happen in generator. Instead of, it will yielding the value one by one, instead of keeping all in a memory. Generator functions will automatically suspend and resume their execution and state around the last point of value generation. Let's say you're generating a list from 1 to 10. So what it will do, it will give you, let's say you start the iteration and you want the first number, let's say 1. Then the next time it will remember what the last number it has provided you, it has yielded you. Then it will provide you the 2, then 3, then 4, instead of giving you all at a time. The advantage is that instead of having to compute an entire series of value upfront, the generator computes one value, waits until the next value is called for. Let's say you don't want all the value at a time from the list. You want one value at a time. So it's better for performance purpose, instead of creating a whole thing and keeping in memory, create one by one, yield one by one using generator. Range function, for example, behind the scene it works like it's a generator, and it function and doesn't produce a list in memory for all the values from start to stop. It's yielding one by one. We'll see in the action. Instead it just keeps track of the last number and the step size to provide a flow of numbers. It will keep track of last numbers, and the step size by default will be 1, and it will keep yielding up to what the limit you have set. If a user did need the list, let's say user want complete list, then you have to convert using list function, list, then range of 0 to 10. It will give you all the value at a time. Let's explore how to create our own generators. So my Jupyter notebook is already running. Let's create one Python script file. Give the name as generator. First, what we are going to do, we are going to see a general function, how we are going to do write a normal function, and we'll do the same thing using generator and see what are the advantage. So let's create a function called get cubes. Here what we are going to, I will pass a number n, and I want a cube of all the numbers up to 1 to n. Get cubes of n. Then what I will be do, I have to keep a list empty. I have to have a list. Then I will append each cube's value one by one. Then start a for loop for x n range of n, means 0 to n excluding n. What we want to do, we want to append each cube's result dot append x of x to the power 3, means we want cube. Okay, and then finally return the result. That's what the normal function we used to write. If we want, let's say we want to have a get a cubes of n value up to n value, what we'll do, we'll simply write this method. We have a list, then we are keep adding all the cubes, and finally we are returning that list. Let's say I want to see all the values inside the list. Let's say let's execute get cubes up to 9. I want to n, I'm passing as a 9. See, we got as 0 to 9 excluding 9 means 0 to 8, we got all the cubes. So what happens here, all the cubes we are in the same we get in the same in the memory. Let's say something, let's say my requirement is something like that: for x in get underscore cubes 9, sorry, print x. So here we want, again here also we want the cubes of all the numbers, but we want one by one, means first we want 0, then 1, then 8, then 27. But here this 8 get cubes is still holding the whole list in a memory, and that's not the correct thing. Instead of, let's say I want first the 0th value, then the cube of 1, then the cube of 2, then the cube of 3, something like that. So each time I am needing only one value. But this get cubes is normal function, so it's returning all the list in a memory. Instead of it, we could yield each number one by one as per the need. So let's convert this normal method into the yield function. For that, let's copy this. Get cubes, we don't want this because yield will not resulting anything. We don't want return statements. Just instead of this, I am yielding all the cubes value at a time. I have rewritten my normal function and I am creating generator here. This function is actually a generator. Okay, now let's check. If I want to see, we won't get any value because it's a generator. Now it's a generator. We want to print the value. For that, same thing, we just copy it. Now this is not holding all the memory, all the cubes in a memory. Instead of, it's create a generator object. Once you iterate over that, you will, as the value go in a for loop, it will yield that value, but the output is same. But this is the way efficient way to print the values of cubes, because it's not holding, this get cubes is not holding all the value in memory, so it's very efficient. Now two functions are left. Two functions more important functions are next and iter function. Let's see how we can use this. This concept also comes in generator. Let's create a simple generator, simple zen. I'm not passing anything here, just for x in range of 3, iter yield x. I'm yielding x. Okay, this is the generator. How we can see this is generator? Let's print the values. For num in simple gen print num. We got all the value. Let's check the type of this. Let's create an instance of simple gen, simple underscore gen. If we try to see, this is a generator. If I'm trying to execute this come as a generator. now we can use our next method in order to iterate all the value at a time. For that, let's say I want to iterate this generator one by one. I can say next of g. I got the first value as 0. Then next of again z. I got the next iterate value. Then next of z. What are all the values inside in that? It will keep yielding. Next. Now it should not print. Instead of this, it's telling it stop iteration because it doesn't have anything to iterate because all the value is already yielded. So that's what the next method we use. The next is one iter method. Let's say s is equal to hello, but here we can do like for x for later in s print later. We can get this value. This s string is iterable, but it doesn't mean that every iterable we can apply next method like this. Let's say I want to do next of s, sorry, next of s. It is telling is it's not iterator, means first we have to convert into iterator, then only we can use this next method. In order to convert this string into iterator, there is a method called iter. For that, s iter is equal to iter s. Now this s underscore iter is a iterator. Now we can use next function over s underscore iter, and we can keep yielding all the values. See, okay, so we are able to yield all the value now on a string. Now because all the values it yielded, so it's giving the stop iteration. So you can ask why when we are doing this for loop on the for loop on this generator, it's not giving the stop iteration exception. Why? Because for loop by default it's keep checking the value is there in the next value is there in the list or not, because it's know that the next value this generator doesn't have any value, and the next it's going to give an error of a stop iteration error. So what it will do, it will hide that error and it will not show you. So that's what the whole concept of generator in Python. We see the main takeaway of this function is the yield keyword. The yield keyword, and we mostly use this. You often use most of the time you won't use this next and iter function, but it's good to know what are those. So that's all for this video from generators in Python. Thanks for watching. Have a good day. Bye.